This arrangement consists of coil springs, tension rod, lower control arm, and upper wishbone.
The shock absorber is contained inside the strut and is a direct-acting telescopic type shock absorber. The coil spring is mounted over the strut inside the suspension tower. The strut has an upper mounting point in the suspension tower. For the front steerable suspension, the strut's upper mounting is bushed or bearing mounted to allow for the steering movement. The control arm mount is fixed or held in place in the vehicle configuration by bushes. The lower control arm is attached to the vehicle body and holds in place the strut, brake assembly, and drive shafts. The shock absorber is located inside the coil spring and is a The shock absorber is located inside the coil spring and is a direct-acting telescopic type shock absorber. The coil spring is mounted between the upper and lower control arms. The lower control arm pivots on bushes. These bushes twist on the lower control arm pin, which is bolted to the crossmember of the vehicle. The lower control arm is longer than the upper control arm. It moves up and down to accommodate movement in the suspension. These are stop and rebound rubbers. They are used to prevent direct metal-to-metal contact if the suspension should reach its maximum limit of travel. The lower ball joint is attached to the lower control arm and allows the steering knuckle to rotate as the steering wheel is turned. The steering knuckle supports the brake station, wheel bearings, and the road wheel. The upper ball joint is attached to the upper control arm and allows the steering knuckle to rotate as the steering wheel is turned. The upper control arm pivots on bushes. These bushes twist on the upper control arm pin, which is bolted to the vehicle's crossmember.
A number of different layouts are used in driven or live axle rear suspension systems. This driven or live rear axle arrangement consists of shock absorbers, U-bolts, fixed shackle, rebound clips, and swinging shackles. This arrangement can...
What was that? Sure does.
A number of different layouts are used in driven or live axle rear suspension systems. This driven or live rear axle arrangement consists of shock absorbers, U-bolts, fixed shackle, rebound clips, and swinging shackles. This arrangement consists of coil springs, flexible bushes, and upper and lower control arms. This arrangement consists of coil springs, flexible bushes, panhard rods, and upper and lower control arms. This arrangement consists of coil springs, flexible bushes, Watts linkage, and upper and lower control arms. This rear-wheel drive vehicle has coil springs in the rear suspension. Therefore, special provision must be made to anchor the axle laterally and longitudinally. Trailing arms or control rods are used to position the axle longitudinally. They have flexible rubber mountings at each end where they anchor on the axle housing and on the chassis frame. They would allow the axle to move laterally if it were not restrained. Any such movement has to be controlled to keep correct alignment with the front wheels and the vehicle frame. This suspension system uses angled upper control rods to limit lateral movement of the rear axle during cornering. They also absorb the torque reaction forces, which limits rear axle windup during accelerating and braking. A panhard rod may be used to restrict lateral movement of the rear axle during cornering. It has bushes or mountings at each end where it fastens onto the axle and frame. This allows for vibrations and load while maintaining correct alignment. The axle may also be fastened by a Watts linkage. A lever mounted on a pivot near the center of the axle housing is connected by rods to the frame on each side of the vehicle. This maintains the axle alignment with the frame while still allowing the suspension to move vertically.
The lower trailing arm assists in maintaining the longitudinal position of the housing. A U-shaped axle beam has a torsion bar mounted inside it. This type of suspension is known as a dead axle. It does not transmit any drive. The panhard rod function is to assist in stabilizing the vehicle from lateral movements. The struts have an upper mounting point in the suspension tower. This is a non-steerable strut, and as such does not require an upper bearing.
A number of different layouts are used in independent-driven or live axle rear suspension systems. This independent-driven or live rear axle arrangement consists of coil springs, flexible bushes, CV joints, external drive shafts, and semi-trailing arms. This arrangement consists of coil springs, drive shafts, crossmember, universal joints, and lower suspension link. This arrangement consists of coil springs and strut, spline sections, lateral wishbone, and external drive shafts. This independent-driven or live axle arrangement can either be front or rear suspension and consists of torsion bar, upper wishbone, lower wishbone, and torsion bar adjustment. One of the main benefits claimed for an independent suspension is that unsprung mass can be kept low. Also, if a wheel on one side hits a road irregularity, it won't upset the wheel on the other side of the same axle. And it allows wheel chambers to be adjusted individually when provided for by the manufacturer. One of the simplest and most common independent suspension systems is the Mcpherson Strut type. It can be used on the front and rear of the vehicle. It consists of a spring and shock absorber unit called a strut. The lower end of the strut is fastened by a ball joint, fitted to the end of the suspension control arm. Its upper end is fastened in a molded rubber mounting. If the unit is on the front, the upper mounting includes a bearing to allow the complete strut to rotate with the steering. A tension rod or stay bar extends from the body subframe to the outer end of the control arm. This maintains the fastening of the control arm during braking and accelerating. In this front-wheel drive suspension, the control arm is a wishbone shape with two widely spaced mounting points. This prevents backward and forward movement, so a tension rod is not needed. Wishbones can also be used in a parallel link system. They can be used in pairs with the coil spring between the lower wishbone and the suspension crossmember. Alternatively, the upper link may be a wishbone, with the coil spring mounted above, combined with a single pivot lower link fastened by a tension rod. On some vehicles, a torsion bar provides the springing medium. Torsion bar is attached at the inner fulcrum point of the wishbone or control arm. As the suspension is deflected, it twists around its center. It can be fitted to the upper or the lower link depending on the type of vehicle. The upper link is shorter than the lower one, regardless of the springing method used. When the suspension is deflected, unequal lengths allow the track of the vehicle to be maintained near constant, but with some changes to camber angle. Generally, when the car leans during cornering, the inner wheel leans outwards at the top, and the outer wheel leans inwards. This helps to maintain maximum tire contact with the road surface.
Adaptive air suspension is an electronically controlled air suspension system at all four wheels with a continuously adaptive damping system. It combines sporty handling with a high level of ride comfort. Additionally, the air suspension allows the speed-dependent lowering of the body. This change in ride height means a lower center of gravity and significantly increased directional stability as a result. The vehicle's handling characteristics are improved at the same time. Some European vehicles have air suspension struts at all four wheels. The information obtained from sensors on the axles and acceleration sensors on the body is evaluated in the Adaptive Air Suspension's central control unit. This computer can control the adjustment of the individual shock absorbers in milliseconds depending on driving situation. Provided no higher damping forces are required, for instance when driving straight ahead on good roads, the damper settings remain comfortably soft. Specific adjustments to the damping force at individual wheels eliminates body movement, which could affect occupant comfort. When cornering, braking, or moving away, adaptive damping can, in some instances, automatically reduce rolling or pitching movements. Adaptive air suspension also offers the advantages of the vehicle's suspension height remaining constant regardless of the load it is carrying, adjustable dampening characteristics and ride height using a single process via the manufacturer's installed car performance menu, and generally an ability for the driver to influence the suspension characteristics and thus the operating dynamics as individually preferred. When the ignition is switched on or when the vehicle's door is opened before ignition, the control system is activated. The height sensor uses the induction principle to constantly monitor the distance between the vehicle's axle and